Okay, for question number 3 on this worksheet, what we're really looking at now is we're looking at a random variable x, which is the life expectancy. So basically, given somebody's 25 years old, how much longer do you expect them to live? Okay, obviously if you were 85 years old, your life expectancy would be a lot less than if you were 18 years old. So this is how life insurance companies figure out what their premium should be. They know about how much longer the person's going to live, and so they base their premium based on that average. So for x, we're told that the mean of x is equal to 50.2 years, and the standard deviation of x is equal to 11.5 years. So this is what they're telling us. If they insure just one person, the distribution is going to be centered at 50, but there is a fairly high likelihood in a relative sense that the guy might only live 30 years or 20 years, or he might live 80 years or 90 years. So how does the insurance company figure out how much they should charge for their premium if they have such a wide range of values of life expectancy? So what they do is they say, okay, instead of insuring just one person, we're going to insure more than one person. And this is an example of what happens. The problem says, let's take a look at the average life expectancy. And what I'm going to do is turn that 0.5 into a 1/2 because the fractions work out better. Each one of these x's represents the life expectancy of one of these people. We know that the mean and standard deviation of each of those x's is the same, however. So the mean of this w is going to be 1/2 the mean of the x plus 1/2 mean of x, because the means of each of these people are going to be the same because they're the same type of person. They're both 25, they're both buying a policy, we assume they're both in the same general health. The variance of w is 1/2 squared sigma squared x plus 1/2 squared sigma squared x. And the sigma squared is the same thing, it's the same idea here in that both of these sigma squares are the same number because they both are the same distribution. If we do a little hocus pocus here and combine 1/2 squared, which is 1/4, and this is 1/4, like that, we can combine these algebraically to get 1/2 sigma squared of x. So sigma squared of w, this new variable, which is the average life expectancy for the two people, is equal to 1/2 the variance of the life expectancy for just one of those people individually. So that means the standard deviation is the standard deviation of x over square root of 2. So what we've done is we've taken our standard deviation for one person, which is 11, and we've cut it down by a factor of square root of 2. So basically divided by about 1.4. That makes a smaller standard deviation. Now let's do this. Let's do the same thing, except now we have 3 people. So we're going to find the average life expectancy for 3 people. Okay, if we do a bunch of hocus pocus here, and I'll let you do the algebra, it turns out the mean of this w is the mean of what x was. It doesn't change, just like this doesn't change. But the standard deviation of this w is now the standard deviation, what it used to be, divided by square root of 3. If we have n policies, the standard deviation of our average life expectancy for the people on those n policies is going to be sigma of x over square root of n. So suppose they have 1,000,000 policies. Take the 11.5 divided by a square root of 1,000,000, and we end up with a very small number, which is what the insurance company wants. They know the mean life expectancy will still be 50, but the variance of that life expectancy is going to be very, very small, and that gives them a lot more certainty in determining what the premiums are going to be.